Go.
Okay, so thinking in terms of the survey that you're going to do on the ground, what the information we're trying to get out of it at the end, and the concepts of the data at the beginning, like that whole flow. And we sort of came at it a bit piecemeal because we've all got different specialties in what we do, and it worked out really nicely. This first part, the transect part, it is determined by the landform. So in Jess's diagram, we have one transect per landform. So we need to know about the landforms and all the information about that. So that's sort of one cluster of information. The transects are broken up into full observations about specific transect, full transect, and the specific observations of artifact or scatters or whatever it is you're finding within each transect itself. So we've got things like GPS coordinates for the start and finish of the transect of the full transect variable, and GPS of specific artifact scatters or artifacts or sediment or whatever it is, that variable within the transect that you're trying to record is a specific under that cluster there. So it's it comes top down this way, and then specific observations within this transect, and photographs relate to all of them. And it's a bit of a separate table, but a separate concept relating to every single variable on the board, really.
Now, I'm actually glad somebody did something a little bit different, in the sense that a lot of the times we automatically go to something like, if we're going to record, a transect and site survey, one entity should be a transect, another entity should be a site, or in this case, or maybe an artifact, or that we think very much about the database components being a mirror of the archaeological things that you're recording. And this instead has thought of them in a different way about sort of whether the observation pertains to the entire transect or is it something specific. And often you can. This is a little bit more like abstract way of thinking about things, and a lot of times it does make sense to do things that way, like record the stuff that has to do with the entire thing, and then record like the full transect observations here, things that have to do with the whole transect versus stuff that is smaller pieces like an artifact scatter or something like that. I mean, I wouldn't necessarily do this particular project this way, but this is a different way of thinking about data than automatically going to, okay, I'm doing artifacts, so I should do fabric shape, and I'm doing ceramics, so I should do fabric shape and decoration. That maybe there's a different way we should think about it, and than just those. So I'm really glad that somebody did that. And there are certain things that I definitely think we should not tie to something like the transect or the artifact. For instance, I think as both of you guys have done, and maybe you guys did it too, that photos should be in a separate photo log. That's definitely the case. Like especially if you're using like a DSLR to take photos, that we don't enter that any one record might have 0 photos. It might have 1 photo. It might have many photos. So it's best to just put your photos separately in a photo log. Photos that you take with the internal camera on the device are always tied to whatever record you're in when you produce them, and it'll clearly say whether you're on in a transect record or an artifact record or whatever kind of record that you have, and so those aren't a problem. But when I say a separate table for photos, I mean like a log for DSLR photos where you want to do publication quality photos. And I guess that is something to say that the photos on the cameras on the devices are very good for like your daily reference shots, but they're probably, when you get into publication, it may be a problem, like they might not be good enough. I'm remembering when the last time we had an article come out in the Journal of Field Archaeology, they were super uptight about the quality and resolution of the photography and the way that the line drawings are done and all of this. That you're still better off using a DSLR for photos that you think might be publication quality. And another thing just to throw in about that is, speaking as the project photographer on a number of projects, is that when you've got your DSLR or a high-end point-and-shoot camera, always save as RAW. Don't save as JPEG. And then after you've shot them in RAW, use an appropriate piece of software to convert it to a DNG file. DNG is emerging as the standard. The way that PDFs are the way you probably want to store documents. It's a standard archival type of document, especially if you use PDF-A. That DNG is emerging as the standard way to archive images, and it has the advantage every time you open a JPEG, edit it, and save it, it deteriorates in quality. So they're not really very good for archival photographs. That you want to get something like a DNG. TIFFs are also okay, but they're huge, and DNGs are more manageable. With the right software, you can also edit a DNG without actually touching the underlying file. It's hard to explain. The editing is a layer that goes over the underlying file, and so the underlying photograph, you're not actually changing the values on any of the pixels in the underlying photograph. This is what I mean by being an archival format. That's my side rant about, as someone who's both seen the repository end of things when we're trying to share photos and the publication end of things, and also then as a project photographer. Shoot raw, convert them to DNG, and use quality equipment when you do it. Photographs are are something that a photo log of DSLR photos is something I definitely split out. As I was sort of saying, we cheated earlier because we had Jess to explain some things with us, and I think. Look, I'm not trained in how to teach database design, so I can make sort of a few comments about yours, and then I can show you how we did ours. So that's about the best idea I can come up with about how to think about these things. But since you can't read mine anyway, and I think you can't see that from down there, I'll just go ahead and commandeer this side board. Are you? Adela or Penny, who was using? Are you done with? Is it okay if I wipe it out? I just realized that you can't. I was just gonna draw over what I had done or what we had done on that board down there, and I realized that half the class can't see it, so I'm going to use this one.
Well, while Sean's doing that, can I make a comment on that one over there that John was doing?
I was not
I
alone.
like how you're pulling out some of the remarks a bit more in a more standardized way. I really like that. I think that there's a lot in those kinds of remarks that you're absolutely right should probably be pulled out as drop-down options or something to standardize that. Because, yeah, I mean, visibility, it was designed to maximize the amount of time, minimize the amount of time, maximize the output, and number of things we could record across kind of a largish area. And as we tighten up this kind of module, then we'll probably hopefully be able to actually produce more data within the same time frame. So actually getting more detail, like, okay, yeah, I mean, looking at the guy who did this initial survey sort of pilot study, it's really hard to pull out stuff from the visibility. Okay, the unit of analysis is transect, and then I want to know visibility across transects and how that correlates, let's say, cobble abundances or core abundances or something. But actually going through and figuring out what it is that's causing that visibility problem makes me have to go through this extensive, detailed, meticulous notes to try to understand, and then actually making spatial sense of that, and then using that to strategize about going into the field of where we're going to plan our next survey. It's actually really hard, because I don't know if it's long grass or short grass, or if it might be seasonal problem, or if it might, what was causing the visibility problem, that sort of thing. So I really like the way that John's done that. That's made me a lot more aware of some of the things that have been going in the remarks that probably should actually be pulled out. Yeah, so thanks for...
Anytime. That'll be 120 grand.
Yeah, that's right. Consultancy rate supply.
So that's actually good. We spent a lot of time on surface visibility on our surface survey, and we ended up breaking it down into vegetation, stoniness, shade, moisture. So like standing water on the on the ground. And I thought there was a fifth one, but I may have
There
forgotten.
was a fifth one. We must not have used it because I don't remember.
Right, no, but we recorded, the subcategories of visibility in addition to doing an overall. I think I can see 60% of the ground here, but we then broke that down. Yeah, shadow, moisture, vegetation.
We also
and
had
stone.
accessibility, I think.
Well, there was
Because
passability and
that's-
accessibility,
that's
but
separate.
those are
If you have a
separate.
difficult terrain, you don't actually see that much because you are paying attention not to fall over.
So, yeah, and then we also, wrote, what land use was, like, is it an orchard, a forest, annual agriculture, perennial agriculture, what's pasture land, we recorded that, and we recorded the agricultural condition where they're harvested. So you might have annual agriculture, and then you'd have seedlings or mature or harvested or whatever we did. Is we were at one point doing a lot of these corrections and analysis based on ultimately on visibility, but that we tried to see if there were which one of these components of visibility screwed up your counts the most. But things that this is, I guess, a good example of things that seem simple on the surface, like no pun intended. That surface visibility should be a relatively straightforward thing. We all understand when we're doing survey that if the ground is all overgrown, that you're going to see less stuff. But then when you start poking at it and you start reading what other people have done with recording surface visibility, you realize that it gets a lot more complicated than that. Like it never occurred to us that shade or shadow was going to be it wasn't part of surface visibility until we read another paper that had been accounting for it, and what a big deal it made, whether it was early in the morning, midday, or late in the day in a plowed field where the furrows all cast heavy shadows over the bottoms, the furrows, and then we realized, yes, this does sort of screw up our artifact counts again. But so things like this. It's good if you can, like first group over here saying, pull that out of the of narrative text, longer text. Being able to pull that out is really helpful, and it does sort of force you to really think about these things when you're doing your recording system, so that you can run analyses on it later and maybe find out what is important. So, but back to the actual underlying data. So we had Jess to help fill in some of this, some of the implicit knowledge behind this, and what we ultimately decided to do. And we're being a little bit more lumpers than splitters. Maybe it's because we've only got like a week to make the module, and we want to get it done. I think it actually works. So we started with a transect table. And we confirmed with Jess that transects are based on landform, and that there will only ever be one landform in a transect. That the landform is, at least in part, what defines the transect. So we put landform straight into it, and of course there'll be an ID and all the things I'm kind of skipping those the administrative stuff right now. In talking through it with Jess, it also emerged that I keep wanting to call it geomorphology. We call it something else.
They were calling it geomorphic summary.
Geomorphic summary. That the geomorphic summary is also critical to the transect, and in defining what we would expect to encounter in the transect and other things. So what we did, if we put the geomorphic summary also in the transect, and we said, whenever either of those two things change, you start a new transect. So again, this is where one of the groups asked, we couldn't avoid workflows. We had to talk about, and the same thing happened to us in a couple of places. And we decided in the future, like currently, Jess has been just recording the transect, like a transect changed when the landform changed. And then we said, okay, well, what do you want to actually record about the geomorphics? Or do you want to, what the single predominant one is? And she said, no, not really, that we need to know if there's two different ones. And then we said, okay, is it enough to know that there's, what's an example of a geomorphic summary?
Well, like if you had a bare bedrock. Well, this is a great thing that, Edgar actually wrote up here for us. Like you've got an example of a slope, right? This is, say, a single landform. From the top to the bottom of the slope with, an estimate of its slope or whatever. But then on it, towards the top, you've got bare bedrock, and then you've got sort of the finer sediments and maybe some of the, even the coarser stuff kind of accumulating at the bottom in some colluvium. So you have a difference in what's exposed on the surface and what the kind of underlying, I guess, matrix is that you're walking across, that the artifacts are embedded within, and yet it's all part of the same landform. So, you know, the actual geomorphic process that's operational across a single landform is going to be different. So it was, you know, it kind of occurred to me, yeah, that, I mean, originally we put that in there because I just wanted to get an estimate of, look, were you walking across bare bedrock or were you walking across the alluvial floodplain, because that's important. But then I started thinking, no, because especially on these slopes, we'd really like to understand what the predominant processes are that are acting across that slope, and so it is useful to know if it's 50-50, if it's 20-80, if it's, you know, what it is that you're actually walking across. So we actually started thinking about it from a process perspective, and especially talking underground, it was pretty obvious that we need to be a bit more cautious there, and then break that up so that although we can still lump it into the landform, which is a useful unit, we can also lump it into, alternatively, you know, just geomorphic types if we wanted to. And also, when we were doing this originally in GIS, we were mapping all this stuff onto an existing geological map, which we digitized. And it was not that useful. We're finding no correlation between geology and other things. And I think that was a map scale problem, which is a totally different problem. You've got this really coarse-grained map scale, and you've got your transects mapping onto it. So I can say precisely, yeah, you walk from here to here, and on the geological map, you're supposed to have walked across this much bedrock. But the reality of what that person walked is what we really like to capture, because it's not really coming across in the existing map column that you're actually seeing.
Yeah, and I think it's important how we talked through it too, in the sense that we started out sort of you know, and we said, okay, in a single landform there might be multiple geomorphic summaries, and then we thought, okay, well, is it enough to know that there are multiple ones, or do we want to know that there are also, like, what the percentage is? And it's like, yes, we want to know the percentage, but then if we know there's 80% and 20%, we don't know whether that 80% is at the beginning, in the middle, or at the end, right? And then we thought, well, that doesn't really help that much, so no, we actually need to know the spatial extent of the you know, of the different geomorphic areas, and so, you know, then we thought we'd have a transect and a subtransect that would divide, you know, that the transect would be defined by the landform, and the subtransect within it would be defined by the geomorphic conditions. And, you know, then we talked about that more, and we just decided that the better approach, and this is again cheating, I didn't tell you about something else that we could do, that instead we would, whenever either the landform or the geomorphic summary changed, we start a new transect, and then later we group transects. And you can write a query that will say, take all of your contiguous transects and group the ones that the landform is the same, the contiguous ones, so you can have a landform thing. And then a second query that says, group the contiguous transects that have that are geomorphically the same. And what that means in the end, so you might have, here's your hillside, that on the landform, you know, that may be one there, and, you know, there, and, you know, there, and there, that these might be, you know, where your landform changes, but your geomorphic summary might change here, and, you know, and here at the same place, that one, and then up here, and then, you know, down here it may change again, and then over here. And each one of, so this is, it would be like 1, 2, 3, 4, 5, a little 1, 6, 7, etc., like that. But we can then run queries on that and say, okay, there's a landform change here, 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 and we can pull out the ones that are land, even though, like, take this right here, there's 2 transects there, but we can group those together because you know, and call this a single landform. And at the same time, we could take these 2 geomorphic ones and group those and say that's a geomorphic contiguous zone. So we can actually do groupings for analytical purposes, and often it's easier to group things than it is to split them up. So it's better to record the atomic unit, the smallest thing that's important, and then we can group them like this later. This is one of those things, we got to this conclusion because we were talking to Jazz, and this gets back to the bigger picture of making data where other people can check your results, can do different things with the data. That we're actually, Jessica's not actually 100% sure whether the landform or the geomorphic conditions are what is the strongest, sort of in contextual factor for where we find tools or cobbles or other things. We don't actually, we can assume that it's a landform, or we can assume that it's a geomorphic survey, but if we record it this way, it lets us actually analyze that and see what is it recorded to, and it lets other people see where it's the finest grain, or mostly another term from database, it's granular. It's broken up into these small pieces. We can group them for analysis if we want, and we can actually run our own analysis to see, rather than assume, what determines where the artifacts or the cobbles come from. Does that make sense? Like, I mean, this is what happens when you start looking at your data this way. You really have to start thinking about, what are your assumptions? Do I want to be able to test it? Am I okay with these assumptions when we go forward with them, or do I want to actually test to see, am I making the right decision by breaking things up by landform rather than geomorphology? So, yeah.
Would it have been much harder to then get at those questions if you'd done it by sub-transect?
It's still this.
Still making the landform dictate.
Yeah, the geo is subordinate, and that could make it difficult to do this. If they're sort of co-equal, if they're both equally determinate, it's easier to treat them entirely independently. Because what if you got to the end of the transect based on landform, but the geomorphic thing continues? If we've divided it, hard, you could do it. It's a little bit more complicated queries to pull it out, and this would probably work okay, but you'd have to. But it still has some assumptions baked into it. We could probably, I'm just trying to run through this quickly we could probably back those assumptions out and reconstruct the data in such a way that we could analyze it to do an independent analysis of landform versus geomorphic area, but I'm not, I'd have to think about that more to make sure. I am more comfortable with giving it, a few minutes of thought to do it like this, where you just have slightly more transects, and hopefully by automating the process of beginning and ending the transects, you just hit a button that says, I'm starting a transect, I'm ending the transect. By automating a few other things, like we can make a button that says, copy over all the data from the last transect, or you could say, copy the landform data from the last transect into the new one, but leave the geo stuff blank, or you could say, copy the geo stuff, but leave the landform blank. So we can speed your data entry by copying all or part of the previous record. So it shouldn't actually, even though we have more transects here, it shouldn't take more time, because when you get here, you say, okay, I'm starting a new transect, but keep the landform the same, but give me a new geo, and I can describe that. And then when I get up here, I can say, keep the geo the same, but I've changed. Here I say change both. Here I say keep the landform the same, but change the geomorphic thing, and etc. You can choose blank them both. Well, you never need to keep them both, or it'd just be part of the same transect. But keep one or keep the other, and copy that in, and that should help to speed up recording so that you can get and we did this on our paper forms when we were working in Bulgaria by just having a checkbox same as previous, for agricultural condition or land use and we can automate that same as previous.
We used kind of an excavation example too. Like, let's say you've got a pit and it's dug. I don't know how many of you can see this, but if you've got a pit and it's over here. This book. So you've got your sort of major surface like this, and it's infilled with something, right? Let's say it's quite thick. So you'd be interested in knowing what's at the bottom of the pit versus what's at the top of the pit, but it's all the same fill. So you might arbitrarily subdivide the contents of that fill into some arbitrary spits, and you call them context 1 and context 2, and then this might be context 3. But basically, when you get to the bottom, here you change because you've reached the bottom of your arbitrary spit. Here you change because you've reached the bottom of the natural layer that it's in. Well, not the natural layer, but the bottom of the feature. So you're changing to a new context, just like you're changing to a new transect, whichever comes first. You meet your arbitrary goal, or you meet a new natural layer. And it's the same kind of concept. You change whichever comes first. You have a new landform or you have a new geology. Because there's probably a relationship between the two. But as I was actually talking to these guys about it, it started to feel a little bit yucky to make that assumption in advance when that's probably something we'd actually want to know rather than assume. So that's how we kind of ended up going there.
Yeah. And then this got me thinking even more about excavations, that an excavation context might change because your soil color changes, or because your soil what do you want to call it, composition changes, and the color may stay the same and the feel may change, or or they both might change, or the composition may change. And there are different reasons why you might change context, just as there are different reasons why you might change transects here. That was actually conceptually, I guess, that defining where transect begins and ends was one of the more difficult things. There was one other tricky thing about this. Some stuff that was easy, we did confirm with Jess that she was happy with, on here, an average surface visibility. So the surface visibility can just go, directly under transect because Jess is happy with an average one. We struggle with what level of detail on our own survey we want to measure the surface visibility at, and this is a decision for a project. But Jess was happy with average, so that's okay. The same with erosion, cobble distribution, and cobble density. So all of those things. Erosion, cobble distribution, which is kind of how nucleated the scatters of cobbles are, whether there's an even scatter or whether it's relatively nucleated or not, or whatever, and the cobble density. Those things are all averages for the entire transect, so we were happy with that.
And again, those arose from the original problem with the remarks, because in its very first manifestation, it was somebody going, there were many cobbles on this transect. There were few cobbles on this transect. And I was like, okay, well, that's useful to know, but it wasn't always in the remarks, so we made it a special field so that there was some sort of estimate of how many there were.
So think about also with things like surface visibility, this is relatively minor, but worth thinking about. Do you want to have people actually put in a percentage, 10%, 20%, 60%? Because then later, how are you going to, this is an estimate, it's probably off by 10%. What are you going to do with those numbers? Because one piece that one transect that's been recorded at 50% and another that's been recorded at 60 is probably actually the same. That there's, in a sense, a false level of precision there. So on ours, we decided to just have 5 categories, 0 to 20%, 20 to 30, 20 to 40, 40 to 60, and you had to choose one of those because we thought that was as good as the estimate was going to be that someone would be making, and we didn't want to imply a false level of precision as if we'd taken a grid and put it down and done that in 10 places and counted the number of, tenths of the grid that were we didn't want to do that. So thinking about whether you record something like a percentage or a range, a range from a drop down is something that is another thing that often comes up. In talking through this, we couldn't really come up with a good reason either to answer Jess's own research questions or really for the reusability of the data or anything to do anything more than the averages on here. That nothing seemed to preclude it. So we decided that yes, these averages over the whole transect for those things were fine. So it took us a couple of tries to make sure we worked that out right. We decided to do separate protolog, as I mentioned, as you guys did. The only other thing that was a little bit tricky for us was then what to do about artifacts, like individual artifacts versus cobble groups, right? And is a cobble group really different from an individual artifact? Should it be the same, or how should it work? And what was really the deciding factor there was we asked Jess, when you have a cobble group, do you still record each individual cobble? And the answer was yes. And then that told us that, no, there's not really a difference between a cobble and an artifact. And so, our other table then, and we decided, there's going to be a photo table. Fine, I won't write that up right now, but I can find, there's a photo log table down here. But we could then do artifacts, and what we would do with the artifacts was have a selector where you chose whether it was an artifact or a cobble right away at the beginning, and then and then again, this was the other place where we couldn't separate so much, or it was important not to totally separate the design of the thinking about the workflow and thinking about what the UI would look like in the end from this, and we wanted to keep the data entry as simple as we could. So, like, if you switch from the table to thinking about a UI that's got tabs on it with different things, that you come across and you get to artifacts, and you select immediately whether it's an artifact or a cobble, and all of the shared fields that you record for both an artifact or a cobble, which is the size, the dimensions. There were a number of other things. So all of the shared data goes on this tab. So you've got under artifacts, you choose artifact or cobble, and then you record all of the shared data. Then artifacts have additional data. So if you selected artifacts, because you've got a radio button here, one's for artifacts, one's for cobbles, and you select, okay, it's an artifact, that then an additional, I shouldn't have called this tab artifact, I should call it a find. Find, this is find. The additional things that you also record about an artifact go in a separate tab, but they could live in the same artifact-specific data can go. They can all live in the same table. We decided that we would tolerate the sparsity of data, the fact that if you're recording a cobble, like that only half this table is going to be full, like you'll only the shared stuff is going to be recorded, whereas if you record an artifact, all will be. So the data will be a little bit sparse, but we thought the trade-off was worth it to simplify to simplify the structure of the database, and that it's the penalty we pay for that that we've got a half-empty table sometimes just isn't, it's not great enough to worry about. It would have been a valid solution to this problem to have a separate artifact and a separate cobble table. That would work. If you wanted to, it's just a matter of trading off how much sparse data you have versus how complex your database is, and we went for the simpler one. And then with these things, we can make groups of any kind of artifact, cobbles or other artifacts, in any way that we can make a general solution to, or a general approach to grouping artifacts. So if you want to then have cobble groups, you can have cobble groups. If you want to be able to group other artifacts, you can, or you don't have to. If you want to only have cobble groups and all other artifacts are just individual finds, that's totally fine. But we could do the same way that we could do grouping on the transects to keep contiguous landforms or contiguous geomorphological zones together. We can do groupings on here, to keep cobbles that are. We can either do it automatically, like all the cobbles that are within 5 meters of one another, or you can actually tag each artifact as being part of the group. So groups are grouping data either automatically or manually is all relatively easy to is relatively easy to do and a powerful tool. Was there anything else that Penny was over there working with? Was there anything else that we did that we should mention? I think that covers it. But I mean, I think this shows that as you work through these things, you get to fundamental research questions like pretty quickly, like. Do I want to be able to test the relationship between, the distribution of artifacts and cobbles versus, just landform and geomorphology. Another project might choose to extend that to prioritize surface visibility. So there are these fundamental research questions that become entangled with your design very very quickly. So I should add that Damien's actually got a lot more experience at database design than I do. What would you do? Would you do anything differently?
Not really. I was struggling because I'm not familiar with the archaeology side of things, which is really important for designing a database to understand what everything means and how it's important. But just splitting it up so you're not duplicating things, but have things separate enough that you can recombine them, like you were saying.
Yeah, and there are a lot of cases. It really helps to have people who are, some of us as archaeologists may decide, the same way that some of us decide we want to learn to use ArcGIS, and some of us decide we want to learn how to do technical drawing, and some of us decide we want to learn how to do field photography. Data modeling and database design, I think, will increasingly be a skill that is useful for archaeologists to pick up at sort of an informed amateur level, which is kind of what I consider that I got, and it's also very useful for us that after working on our project for a couple of years, Brian is starting to develop quite a bit of, he's developing domain knowledge about archaeology too, and getting technical people and archaeologists to work together, having. I've seen in archaeological projects around us that there are a few people like Beatrice McLaughlin at the University of Sydney who's sort of developing a sideline in archaeological information technology, and I see her appearing on different projects and developing that kind of expertise, both on the archaeologists who know about the IT stuff and IT people who have a little bit of domain knowledge about archaeology, and then getting those people together can be really, really, it can be really useful. So that's one of the things we're trying to do with our project too, is develop expertise on both sides. Any questions about this? Criticism, things you think would do differently? Some, was this a mistake? Lumping, being happy with all of the averages for these, for these things across your transect? Would you do anything differently?
Are you recording the exact location of every artifact that you're finding and taking like a GPS look into it? You can then relate back to where the transect is found. Yep. So you can actually, you don't really need to estimate the artifact density on the transect, because isn't that information already contained in the artifact database?
Well, it's cobble density because what we've got is landscape that's just full of millions of artifacts. So it's unfeasible to record it simultaneously. So what we're doing is we're walking across and we're just recording chords to get an idea of the technology involved through use across the landscape. But then we're going to, the new kind of phase of the work that we haven't talked about here is every sort of half kilometer or so, we're going to stop and we're going to do an intensive record every single artifact in the surface.
So you still need that estimate of what's...
Yeah, so the artifact, it's not really ever going to give us an artifact density estimate across the transect, but the cobble density estimate is just a visual idea of basically, that way we can say, okay, places where the person has walked and noted there are lots of cobbles, are those correlated with there being artifacts as well? So it's trying to understand the distribution of the artifacts versus the potential raw material variation. Yeah.
And we run into, even though our survey methodology is quite different and we're using this Mediterranean total coverage surface survey, we run into some very similar things about that we do a rolling estimate as we go along. We imagine 5 people spaced out 20 meters apart, and every 20 meters we call out an estimate of density for the number of artifacts for the previous 20 meters, right? And then we collect diagnostics as we're going along. But then something else that we also do is that if we find an artifact concentration, depending on its size, we will do 1 or more total pickups, like where we draw a 5 meter square or a 10 meter square, and have 3 or 4 students crawl over it on their hands and knees and pick up every single artifact that's on that, down to the chromiest, most deteriorated ceramic, and it's often sort of shocking. You'll say, oh, I had a surface density of 5 shards per square meter, and you rope off, a 5 by 5 square, and you end up with like 2 kilograms of pot shards over it. And what's that John Cherry that said that the finer, he wrote an article that the more time you spend surveying a given area, you'll always find more and more and more artifacts, and there's no sort of...
Log and weight.
Oh. Yes. The best named archaeological survey article ever. What is it? Flog, and wait. Yes, is about the never-ending. How you'll always find more artifacts the more time you use. So that's why it's important. Like on our survey, when we're doing the initial estimate, we have no matter how many artifacts people see, we have them keep walking at like a meter a second to. And making the best estimate that they can, and this is how we initially define our surface concentrations, and then we go back and do total pickups for to do data chronology and functional analysis of the site represented by the surface scatter. But anyway, we're getting too much into survey theory now. So, no, any other questions about this? Yeah, are we happy? Is there anything else on our agenda for today, Penny, that we...
Only talking through module scoping.
Oh, thank you. This we can do very briefly, because this is the hard work of module scoping, what we just did, and we just wanted to briefly introduce how this actually looks when you do it. If you want to work with us on a module, and Andy and Jess can, I think, more or less confirm this, that you contact us, send us your forms, send us some of your reports. We'll set up a folder on Google Drive, and we can share stuff that way. We will go through and make a first guess at stuff like this. We'll send it to you just as or we'll put it up just as a Google Doc or something like that about what we think should be recorded under each of your entities. We go back and forth like that a few times. It's good if we can see your forms, your reports, and a sample of your data. Like if you've got some scanned forms that are filled out, that's really, really useful. So you send us that. We do an initial scoping like this. We go back and forth with you till this is more or less, where you want it. And then, depending on quite how rushed for time we are, if we have time, we will then do a mock-up of your of what a user interface might look like. And then this is where it gets into your workflows and how there's your data on the one hand and your workflows on the other. We'll do a mock-up of your user interface. We do wireframes for that. Penny's got a picture of one of our wireframes if you want to see one later. But we do wireframes of what you're and share these again on Google Drive. You look at them and you say yes, this is what you want, and that's generally when we'll get some kind of sign-off saying yes, this is really what we want you to develop. We weren't quite as formal with Andy and Jess because their development is sort of prepaid through UQ's contribution to our ARC grant, so we weren't billing them by the hour for it when we do commercial development for commercial archaeological consultancies. At that stage, with the wireframe, we provide a cost and time estimate based on the wireframes, and then we get sign off from the client if it's paid work like that. And then we'll develop a prototype and go back and forth with the prototype. We kind of skipped the wireframe stage with you guys. I think I went straight from sort of doing this kind of work that we probably asked you piecemeal instead of giving it to you all at once to developing a prototype. And now we're going back and forth with the prototype, which is what you guys helped us with yesterday when you filled out those when you played with the app and filled out those forms for us. So that's basically how it works. What did I miss?
Oh, I just wanted to mention with Jess and Andy, we were also branching from an existing module, so the process was a bit different for them as well. So they both got, what we did is we took our generic workflow and added custom fields, added custom vocabularies where we had them, and the rest of it kind of looked like junk. So some of the initial responses were, this wasn't on my form, and that's because we're working from a general model, and it's much easier to take things out than put them back in. So it can be different. If it's an all-new workflow, you'll get something, your first cut will be closer to what you're expecting, and if it's branching from an existing work, there can be a bit more to and fro. But you get it done, instead of the static wireframes, you get a live module to play with for that first cut, so it can be different depending on what you're after.
Yeah.
Can I just ask what a static wireframe is?
Oh,
Do you want to pull one?
Yeah.
I was just going to say.
It's a pretty picture where we mock up what it will look like.
Okay, so it's just like a flat
yeah,
diagram of how
it's a drawing
Yeah, okay.
basically, so you get a rough idea of how things will be laid out.
No, it's not.
So.
Well, I was gonna just chip in there from my end, working with you guys. I got as much information together as possible and threw that. Yeah. What I realised, in fact, it was just the other day, where it was part of this sort of to and fro, and is that quite a lot of information that I had thought was very clear in the documents really wasn't, and actually there were a lot of very specific things about the recording system that were either inside my head or I just assumed everybody would know. And it's kind of interesting, you know, going from lumps of paper and corporate memory to something that's explicitly defined that somebody else can understand very easily and in a sort of remote way like that. It was that was a very educational process for me. But yeah, it also, the thing is just, there's a couple of things. First of all, that process really helped me to get all of this stuff clear in my head, which is great. But also be very, having that clarity it'll help these guys to develop your product very more quickly, I would suspect. I mean, there might be one or two less episodes of kicking the ball back and forward. But yeah, clarity, and I was quite amazed at how that transformation into it's not just taking a whole lot of information and throwing it into a module or something like that. This has definitely been about completely restructuring and engineering and defining a whole lot of things as well. So I think that's a very positive process, actually.
It often, and as we saw in a small way, but just that often happens. That you have to think about, how am I defining my transect, and things like this. They always come up. And I still, now when this happens, I still think back to the first database class I ever had, where the guy instructor says, I work with small businesses all the time, and every time I sit down with them, they end up, when they move from, paper records or sort of ad hoc, spreadsheets, these sorts of things, to a database that manages their inventories and their payroll and this, all these other things, that they inevitably sort of overhaul half of their operations when they do that, because a lot of implicit knowledge gets made explicit, and you start thinking about the implications of it.
It's not just a transition; it's an improvement.
Hopefully,
that's what I've got from it.
It's an opportunity for improvement, I think, because you have to think through things really carefully, and it's a good time to do, stock taking about your recording and seeing if you're really getting getting what you need out of it.
It's like making an international move. Is it really worth keeping this?
Has this been in your mind recently?
The point of this that I've been storing under my house for 5 years. Why do I have that?
When we likewise, it's what should I get rid of, and it's also when I moved here from the States, it's like, okay, UNSW's throwing X amount of money at my international move. What do I really need to go to Costco and get that I won't be able to get in Australia, cheap when I move down there?
This has been recorded, by the way. There'll be an email coming from your chancellery right now.
So I had to take advantage of their international relocation, and
Your databases, they just get bumped up, don't they, over time, and you make little quick fixes as you go because you need to record a certain extra thing or whatever. And what this process does is it makes you go back and critically examine all of that and just clean it all up.
Yeah.
So it's really useful.
This is what wireframes look like. It's a mock-up of what of what you'll see on the screen of your device in a given tab or tab group, and what the controls look like. So this is what we normally, and the arrows are what screens come up when you push what buttons. We provide something like this for you. And yet, development times and costs are coming down as we build up our library. Like Penny mentioned, that we've got an excavation, a general excavation module now that we're pretty happy with, and Andy and Jess is doing theirs. We've fed a lot of the changes or a lot of the things that they do in their two excavations. We fed those back into the general one because, like Penny says, it's much easier to take things out than it is to put than to build them. So we're making this sort of, maybe it's a little bit overkill, but this very generalized, detailed excavation that in future we hope people will either be able to use more or less as it is, or just go through and say, drop this, drop this, drop this, and all of that is super easy, and then I need you to add this to it. So we're hoping to build up a library of these sort of general projects or modules like that can be used for various things. And to encourage that, like when we do our, and this is again a very sort of standard approach that's taken from open source software development, that we give, if you're willing to let the work that went into your module get fed back into, like if your university doesn't put in a significant sort of 5-figure donation to a Leaf, so we owe you lots of work, if you are actually paying for it, we give you a discount for developing in an open way, meaning other people can reuse your work. Some consultancies have come to us and said, no, our workflows and our forms are proprietary. We must keep them secret, and then you don't get that discount if you want them kept secret, because that raises the price. Like, if you do contribute your module to our growing module library, that reduces everyone else's costs in the future, and I think people should be rewarded for that. So that's one of the things that we do. So, and we just took yours and used it however we wanted. So that's
that's cool, man. Cool.
It's big pieces of it. I think are being used in Peru, right, as we speak.
Right.
Yeah.
Can I have a quote? Can I have a quote from you on that? Just to say, yeah. Impact of research outcomes. Fantastic.
Give me the quote in Spanish.
You can do Spanish module and the
Hey, great.
It's all in Spanish.
I think that's. Is there anything else that I should add about the process of scoping and if you?
What I would throw in perhaps is we do have a couple of these prototypes. It lets you, if you compare them to the modules, the sample modules that you can download for free, even if you use Google Play and you download the app on your own personal device, there is a pop-up that says, do you want to download some sample modules? You say yes, you download them. You can then compare them to these wireframes, just to see again what is actually behind, what's the structure of this entire model, to see how complex it is, whether it suits your needs. It's just kind of like an instruction guide to what's happening. It is also much easier than to communicate with us, to say, yes, I want that picture dictionary, or no, I don't want picture dictionary, I want to drop down, just to kind of get the sense of the vocab and what are the data types that we can use, just so that you have the whole breadth of what's on the table, what can be done.
So, yeah, no,
I think that we'll probably put some of these, make them public. So
we're getting ready to do an overhaul of all of our website documents. We've started on it. It's not done yet, and we'll put up a number of these wireframes up there. And yeah, I think that they do make a nice overview and guide to the module when they get done. Some of those interesting things that came up were in individual conversations over the course of the last couple of days. So if anyone wants to talk to us, I encourage you to do that. Other things that actually specific things that came up in those conversations that you probably saw when you were doing the modules, just to make sure we can do things like picture dictionaries, where if you want to identify a particular kind of masonry, you can like have pictures of that or drawings of it and select it just by tapping on the drawing. And the other thing that may not have, I'm not sure, it might be in your module, I can't remember, the way that we can step people through something like, let's say you want to decide whether your soil, how much clay, how much silt, how much sand is in it, and you like roll it into a sausage, and does it break apart? And we can actually step through one of those, like, that gives you the instruction, roll it up, and asks, does it break into pieces? And if it does, then you hit yes, and then it has you do the next test. It's a flow model that we stole from someplace, borrowed.
Cambridge manual.
Cambridge manuals are not.
So there's another email code.
We can, if you're training students or you're working with community members or something like that, these kinds of flow decision trees like this can be really, really useful. I mean, I don't remember how to like look at the soil and immediately tell whether it's silty clay or sandy silt or whatever it is. And so I find it quite useful, and I'd like to actually, one of the things that we're going to be working with UQ and Southern Cross University, which is another one of our partners on, is actually doing seeing what else we can do to improve the utility of the application by doing things like taking Andy's archaeobotany reference collection and taking pieces of that and putting it onto the device for you to take out into the field. And that's going to be sort of UQ's contribution to it, is working on how do we deploy reference collections to the field on the device, even when you're offline. And the other thing Southern Cross, and Bill Boyd at Southern Cross is helping us with, is going to be to develop more of these workflow things in the field, like particularly for archaeological sciences, like, suddenly I'm excavating and I found a hearth and I want to do geomagnetic, paleomagnetic dating on it, but there's no, there's no geochronologist for 2,000 miles. What do I do? And and here's a flow. Here's a flow for how you take a geomag sample, or an archaeomag sample. Things like things like that for sampling and other things. We're trying to develop again sort of a library of these things that can be used to help people with processes like this. Things that when you need to do them, they're really important, but you don't have to do them very often, and so you may not have a specialist. You may not remember how to do that because the last time you did it was a year and a half ago, and yes, I need to mark on my, on the little piece of perspex that I'm taking my archaeomag sample, whether it's like true north or magnetic north on the arrow that I draw on it, this sort of thing. These are some other potentials of the software that we're finding that we didn't necessarily think of at the very beginning, but then there's a typical sort of cycle to introduction of new technologies. One where we just duplicate what we've been doing in the old technology, and then a later cycle where later stage in the cycle where we start discovering the new things that we can do in the new medium. And I think we're starting to get to the point where we're seeing some of the new things that we can do in the new in the new medium. So. We're happy for any ideas, or if you're interested in that sort of thing, we can put you in touch with Bill, and we'll be working with him. And there's lots of opportunities for this sort of thing. And the last thing I'll say is we're going to come looking for some of you, probably because we let Sean Alm talk us into promising a session at the AAA next year about.
Sean's very good at that.
About field experiences with this software, and so and what it's like moving to a digital world with in field recording. And we don't want to. I'll probably give a 15-minute update on the project and where it's at like that. But most of the session should be actual field experiences. And being critical is fine. You don't have to be a big. We're not expecting everybody to toe the party line on the in the session. But we thought this would be a good. Since Andy you're only allowed to be first author on one paper. This might be a good thing for a postgraduate student or someone to be the first author.
Am I in another session?
I don't know. I just figured, a big shot that you are.
I can't plan that far ahead. I've got to drink beer.
Abstracts are due at the end of June. So, but at this stage, it'll just have to be, this paper will, detail the result, the experiences. It's the same thing we all do for fieldwork results that we put in the.
You want to hope it works?
Yeah. So, but Andy or Jess may be coming to you to talk to you about somebody doing some presentations like this at the AAA next year, and we're very interested in your results as well. Okay.
Thank you.
See you in higher learning.
And do you have our contact? So because I don't think I ever got. Oh, you've got a card. Okay, perfect. Thanks for coming.
Nice to meet you all.
See you.
Okay. Penny and Adela told me I had to finish by 3. We've got. We'll be hanging around playing.
13 minutes if anybody wants to ask any additional questions, and I will then take Jess and Andy through the FAIMS in the Box setup. So if anybody is interested, we can do that as well.
Yeah, that's everything I wanted to. Sorry, I thought I saw your hand. No. Yeah, any questions about this, about anything else? I always get lots of interesting questions from individual that you're as bad as my students. They come up to me after class and ask me the most interesting questions that they should have brought up in the tutorial.
Did you have a chance to look at your sketchbook pro?
Not yet. I was meeting, sorry, we met with Jane over lunch to see what they were up to. But yes, we will, while Adela is doing the FAIMS in the Box setup, I will look at the workflow for Sketchbook and see where the bottlenecks are and the problems are. Anything else?
No, it's the module anyway.
We did have a last question about